Hello friends, welcome to Fishery Base once more. Today we will be handling a very important topic. How a pond's shape affects the overall yield. As we all know, we get into a fishery business not just for leisure but also for eventual returns. If your main aim is for profit making, you will like to evaluate the cost of production in order not to be at a loss. So it is very crucial to also evaluate even the shape your ponds will have too. A fish pond may be constructed in various shapes depending on the topography and space available for pond construction. Based on the site topography, you can decide which pond shape to adopt in certain areas. A fish pond may have any shape, as seen from barrage ponds, whose shape depends exclusively on the topography of the valleys in which they are built. Ponds can have a regular shape, for example circular, square, or rectangular ponds, or may simply be designed irregularly to occupy the land available. Any pond that is neither a circle, square, or rectangle will generally be classified as an irregular pond. A typical example of an irregular pond is a barrage pond. The water settles to occupy the shape of the land above the barrage. Let us examine the main regular pond shapes. Rectangular ponds are ponds whose length is longer than its width. Square ponds are ponds whose length and width are equal. Circular ponds are ponds whose walls or dikes enclose to form a circle. What pond shape do you eventually choose? A round pond? A tight and rectangular pond shape? Or rather a naturally shaped pond or irregular pond? Before we dive into comparing the various shapes, let us understand some facts. As a matter of fact, choosing a particular pond shape is a matter of taste, culture, and preference. A shape may be chosen because of the design of the remaining part of the garden or farm. Besides, for most ponds, the shape may not be of importance. Except for koi ponds, where the shape is very important indeed. The water in a pond should stream to the effect that the waste goes to the skimmer as or bottom drain S of the pond. A lot of questions are asked by aquaculturists when trying to choose the suitable pond shape to adopt for their farm. Between circular, square, and rectangular ponds, which is the cheapest to build? Which will occupy the least space possible yet deliver optimum yields? Which is easier to access and manage, especially during the feeding of fish? Which of the pond shapes favors rapid water renewal and easy circulation of water in the pond? Let us start with question 1. Which pond shape is the cheapest to build?
Generally, sunken ponds and diversion ponds are designed with a regular shape, either square or rectangular. Scientifically, for the same pond size, the total dike length regularly increases as the pond shape gradually deviates from square and becomes more elongated. Therefore, since the narrower the pond, the more the space occupied by the dike, it will imply that rectangular ponds are more costly and occupy more land space than square ponds. Let's find out that by calculating the dike area for circular, rectangular, and square ponds.
Assuming we want to construct a 100 square meters pond. For a circular pond with an area of 100 meters square. Consider a circular pond as having the circles as shown in the image below. Using the formula, area equals pi times radius square. Since the area of the pond is the same as that of the inner circle area, AI, we can conclude that the area of the inner circle, AI, with radius r is 100 square meters. From the formula above, solving for small r gives small r approximately equals 5.6 for 19 meters. Now let's calculate the area L of the outer circle with radius capital R.
Capital R equals small r plus to meters, which implies capital R equals 5.6 for 19 meters plus to meters. Thus, capital R equals 7.6 for 19 meters. Thus, AO equals pi times r squared, which implies AO equals pi times 7.6 for 19 square. Solving for AO gives AO equals 183 for 6 meters square. To get the area of the dike, AD, we subtract AI from AO. Thus AD equals 183 for 6 minus 100, which gives 83 for 6 square meters. Now that we already know the area of our circular pond's dike, let's move ahead to determine the area of our square and rectangular pond's dike in the following section. For the dike area for a 1 square pond, area of square dike will be perimeter of dike times width of dike, which implies length plus width times width of dike, which gives 10 meters plus 10 meters times to meters. Thus, area of its dike equals 20 times 2 equals 40 square meters. For the dike area of a 100 square meters rectangle pond, that's rectangle 1. Area of rectangle 1 dike will be perimeter of dike times width of dike, which implies length plus width times width of dike, which gives 15 meters plus 6.67 meters times to meters. Thus, area of its dike equals 21.67 times 2, which is 43.3 for square meters. For the dike area of the second 100 square meters rectangle pond, that's rectangle 2. Area of rectangle to dike will be perimeter of dike times width of dike, which implies length plus width times width of dike, which gives 5 meters plus 20 meters times to meters. Thus, area of its dike equals 25 meters times 2, which is 50 square meters. From the calculations above, we can see that the dike occupies the largest area with a circular pond, i.e. 83.46 square meters, followed by the narrow rectangular pond, i.e. 50 square meters, thirdly by the less narrow rectangular pond, i.e. 43.3 for square meters, and then the least area with the square pond, i.e. 40 square meters.
Let us go back to our question. We can then draw the following conclusions about the cost of the various fish pond shapes. As regards the cost of land, we may conclude that a circular pond is the most expensive, while a square pond is the cheapest. You will also find that compared with circular ponds, rectangular and square, ponds are much more cheaper if you can build a group of them with shared walls, dikes. When circular ponds are joined to each other, there is always an interlocked portion of land that would have been exploited, causing more waste of land. It requires more technical skills to carefully curve out the walls of a circular pond to come out linear and smooth, especially when it is an earthen pond. At the same time, the construction costs increase. The above points go a long way to support the many reasons why circular earthen ponds are rarely constructed, especially jointly with each other. Question 2. Which pond shape will occupy the least space possible yet deliver optimum yields? From the analysis in the above section, it is crystal clear that circular ponds occupy the most space and square ponds occupy the least. There are cases where it may be simpler and cheaper to match the shape of the pond with the existing topography. Question 3. Which shape is easier to access and manage? In this image, you notice that the center of the pond can be easily attained with a narrower rectangular pond. This means that during manual feeding, the feed can easily reach the pond organisms at the pond center from either side of the dike length. Question 4. Which pond shape favors rapid water renewal and easy circulation of water in the pond? When it comes to water renewal and easy streaming, the idea is to eliminate dead spots, also known as hypoxia or low oxygen areas in the pond. The best circulation occurs when there are no angles in the ponds. That makes a circular pond is more preferable because its walls do not have angles to give room for dead spots. Between rectangular and square ponds, if the water flow is parallel to the pond length, we should note that the slimmer the pond, the more the water circulation. This is seen with raceways which have high water renewal and oxygenation. Tips on pond shapes. Here are some tips to follow when implementing any pond shape of your choice. Allow good access paths around the pond for humans and maybe vehicles. Avoid complex shapes because they are more time-consuming and expensive. Avoid creating tight areas like several angles where water will have trouble circulating. For more information on today's topic, consult useful information in the description section below this video. If you find this video educative, please click on the like button. Equally, click on the subscription button so that you will be notified whenever we upload another educative like this one. It has been your favorite teacher, Dr. Fish. Thanks for watching, and see you next time.